All right, here we are coming to you live from my favorite class, Algebra 2B, Law of Cosines. All right, when do we use law of cosines? For right triangles? Does it work for right triangles? You guys are going to have to speak up if you want that.
Non-right triangles.
Oh, that was Kati. Trout. Non-right triangles. Okay, good. So if you have a non-right triangle and law of sines doesn't work, if law of sines does not work, then you have to use law of cosines. So this is for when the law of sines doesn't work. Go ahead, you can ask questions. All right, so I think the question you were going to ask is when does the law of sines not work? So let's say we had like, I don't know, 30-degree angle there, and we knew this was 21, and we knew this here was like, I don't know, 19 or something, and we want to find this one here. Okay, you can't use SOHCAHTOA because it's not a right triangle, correct? Just for reference, they're nodding. So you can't use the right triangle. You can't use right triangle trig. You can't use law of sines because when we try to set up law of sines, you'd have the sine of 30 over x, and then I don't got another angle. I have no other angle. If you don't have another angle, well then you're going to have two missing values. See, I'd be like the sine of I don't know. I don't have another angle over 19 or whatever. So the problem is you have two missing things. You can't use law of sines. So if you can't use law of sines, you have to use law of cosines. Okay, so we started talking about using law of cosines. We did one example yesterday. Let's do a couple more here to start. Right? So when you set up law of cosines, you always start off with whatever angle you're using, its opposite side starts the whole formula off. So in this case, I want to know this value right here. And I know the other two, but I'm missing one. And the opposite side of the angle we have starts off the whole equation. So we're going to start off with x squared equal to, all right, and then if you go back and take a look at the formula here, the formula can be written three different ways. I think I covered this yesterday. It's written in terms of c right here, but I also could write it in terms of a. And so if it was a squared equals, it would be the other two, b squared plus c squared minus 2 bc cosine of a. And the thing to take notice of is that the angle, whatever angle you're using right there, its opposite side is the one that starts off the equation. That's what I was talking about before. So how do you know to get started? How do you know which one starts it off? Well, it's whatever angle we have, its opposite side starts it. Okay? So now we're going to have plus like BC squared. Well, BC, our B and C are 400 and 375. So I'm going to take my 400 squared plus 375 squared minus 2 times those numbers. And then finally times the cosine of, and then we have the angle 35 degrees. So what we did then is we take our calculator, and we have the TI Inspire. So we're going to take that, and we are going to, because we want to know x, so we're going to take all of that stuff, the square root of all of this stuff. So all of this stuff in here, let's just highlight it in green. All of that stuff in green, we're going to take the square root of all that stuff. And we'll just type it right in the calculator, just one big long expression. I don't know what happened there with my students. They started hooting. Here we have the calculator now up. And if you're going to calculate that law of cosines expression, so we're going to have to we're going to calculate all of this, and you're going to take the square root of all of that stuff. So you just type that all in your calculator. Square root, all that stuff, one calculation. You hit enter one time, and you come up with a value of 234.3 if you round it. 240. What was that? 200 and what? Say again. 34.3. 234.3. And we're talking about meters. 234.3 meters. Does that make sense? That's a pretty small angle there, 35. So it makes sense that this side would be smaller than all of the other sides. So now we know one of the sides, right? Could we now find an angle? Could we find an angle now? Do we have enough information to find an angle? We have not found an angle yet. Let's look at finding an angle. Whoops. Okay. Let's do this same problem and let's find an angle. So let's get rid of some of this stuff and we'll find an angle. Okay, there, we clean that up and we're going to find an angle now. This is much more difficult to find an angle. There's more calculations involved. So what angle do we want to find? Let's say we want to find this one right here. Okay, so if we want to find this angle, it doesn't matter which one we find first because they all have to add up to 180, remember. But if we find this angle first, then which number is going to start off our whole equation? Remember, it's the opposite of whatever angle you're using. So if we want to find this angle, then this number, this value, is going to start off our whole big long equation. So let's start off, and I'm gonna go down here with it. So we have 400 squared equals, hold on, wait, what? Oh, you could use the law of sines for this, yeah. Yes. Now you could use law of sines. Let's just pretend that we forgot about that, and let's do law of cosines. Just because we haven't done this yet. So 400 squared equals 375 squared plus 234 squared minus 2 times those values it's actually 0.3 times the cosine of x. So now the difference between this and the last example is that my missing value, my variable I'm solving for, is essentially, it's the angle. It's attached to the cosine of x, the angle. Hold on, let's see if we can get Chase snoring on the video. Oh. So I have to get this expression for cosine x all by itself. So how can I get that all by itself? Well, this looks really messy, but it's not too bad. Let me just group some things together here. This right here is a value, and this right here is a value. This right here is a variable, and this right here is some numerical value. So let's rewrite this a little bit to help us get an idea of what is actually going on. What's 400 squared? It's 16,000 or 160,000. How many zeros? 4 zeros? So we're talking about 160,000 there. Okay, this is where I'm going to need some help. Equals, what's 375 squared plus 234.2 squared? Hold on, 195,474 0.64. Okay, we'll just do 0.6. All right, and then minus, what is 2 times 375 times 234.3? Negative? Oh, minus. Okay. So what we did here is we took that and we made that there. We took that and we calculated and made that. We took that, we calculated, and we got that. Now this is just like an algebraic equation from like algebra 1, except for we have the cosine of x as our variable, and the numbers aren't very nice. Let me just stop and let me just ask a separate question right now. I'm going to go to a fresh page. I'm going to ask a separate question. Let's see if you remember how to do this. 16 equals 20 minus 4x. How would you solve this linear equation? 16 equals 20 minus 4x. What's the first thing that you would do? Subtract the 20. Good. So I'm going to subtract the 20 from both sides. Okay. So now over here I'm left with negative 4 equal to, and then on the right side, negative 4x. Okay. You guys understand why you do that? You agree with that? If I go back to this messier looking problem, that's the same exact idea. What am I going to do first to solve this? I'm going to subtract 195,474.6 from both sides. Whoops. So when you do that, you end up with, you calculated the 195 wrong? Okay. 521.5. Thank you. Way to man up and own your mistakes. Good job. So slightly different there. We got a bad calculation, but we fixed it. So this right here is actually a little bit off. So now if I subtract this, I end up with negative 35,521.5 equal to negative 175,725 times the cosine of x. Now what do I need to do to finish this? We'll go back to the problem that we were just looking at. What do I need to do to finish this off? Divide both sides by negative 4, right? And then my variable will be all by itself. X is equal to 1. If I go over to here, what do I need to divide both sides by with this problem? Negative 175,725. Yikes. All right, so now I have my variable is going to be all by itself. The cosine of x will be all by itself now. If I want to solve the cosine of what degree, what angle is the cosine value going to be equal to this ratio? Negative 35,521.5 over blah, blah, blah. Well, what is it? That's going to be a number between 0 and 1 somewhere, right? Which makes sense. The cosine values are between 0 and 1. Been working with the unit circle. So let's go back to our calculator and let's calculate that. So let's see here. Make that smaller. What were those numbers?
Divided by negative 175,725. No. Is that right?
Is that not right or what?
That's right.
Okay. Thanks for doubting us, Alex. All right, so that value is going to be equivalent to like 0.2. Now, if we think about where on the unit circle, where is the cosine equal to 0.2? Let's just go back to our unit circle for a minute and just think about this. Where is the cosine equal to about 0.2? Well, 0.2 is a little bit to the right. It's not halfway. It's probably about quarter of the way through. So we're talking cosine is to the right and left. We're going to the right about 0.2. So maybe we're talking about like right there and even right there, right? Now, is this value down here, this one, is that going to make sense for a triangle angle measure? No. This is like going to be over 270 degrees down here. Well, over 270 degrees, you can't have an angle over 270 degrees in a triangle because they only have 180 degrees altogether. So we're going to use this one up here. So when I evaluate this in the calculator, I want to do the inverse cosine of that measure. This is like looking it up in the table in the back of the book. What cosine value, for what degree is a cosine value equal to 0.2? Or on my calculator, we have calculators now, I can take the cosine inverse of, and then I can type in control, let's see, where's the ANS button on here, the answer? Is it control, too few arguments, function, blah, blah, blah. Is it this answer? I can't read the board here. Yeah, okay, so that ANS is that previous answer. That's going to put this whole value in right there. So it's going to put it all in there for you. 78.3 degrees. Does that make sense with my picture? Does this look like it's about 78.3 degrees? Looks pretty close, huh? Because this is, you know, right here is 90. I like that. Does that make sense? Okay, so I'm going to conclude that my answer is correct. 78.3 degrees. So when you're calculating the angle on law of cosines, when you're finding the angle, it's a lot more work because you actually you're using some of your algebra. When you're finding the side, it's just a matter of plugging everything in the right spot, and then you're going to let your calculator do some work there. All right, that's it. Quick round of applause for me. Michaela, you're not clapping. Thank you. All right. Oh, one round of applause for you guys today. Those of you that stayed awake. No, this is just me clapping. Good job for those of you guys staying awake today and paying attention. Good job. Those of you guys who are waking up today, mid-lecture and getting in. Those of you guys who are always awake and paying attention, extra high fives for you. All right, we're done.